Hi students, let us continue with the spanning tree topic. So in the previous video I explained about the minimum spanning tree. Actually this minimum spanning tree can be constructed by using Kruskal's algorithm and the Prim's algorithm. So let us discuss what is this Prim's algorithm and the Kruskal's algorithm. So the main thing you have to be noted that Prim's algorithm uses only vertex, means based on the vertex we are deciding a path, that is a spanning tree. And the Kruskal's algorithm uses edges. Now let us see first Prim's algorithm. Prim's algorithm. So mainly it is used to find minimum spanning tree. So whatever you are taken, whether the Kruskal's or the Prims, the main aim of is to find the minimum spanning tree. Now let me write the algorithm for the Prim's algorithm. For step 1. We have to select any connected vertices. So we are discussing Prim, so we uses vertex. So first select any connected vertices with minimum weight. Next step 2. So in the step 2 we have to select unvisited vertex. So first we visited some vertex, after that we have to select the unvisited vertex. That too which is adjacent of the visited vertices with minimum weight. So that is the rule, because first we have to select any one of the vertices that is having the minimum weight in the edge, and the next in the step 2 we have to select the unvisited vertex but which is adjacent to the visited vertex. So it should be like here or here or here, means which is adjacent to the visited vertex. So this is a visited vertex and we have to select the unvisited vertex which is adjacent to the visited vertex, and that vertex should be with minimum weight. And step 3, we have to repeat this step 2 until you visit all the vertices. Repeat step 2 until all vertices are visited. Okay, now let us see one example how this Prim's algorithm will work. So we will apply this algorithm on this example. Let me take the example. So this is one spanning tree. So I am taking the graph. So now I have to convert this into minimum spanning tree. So graph is which is with all closed loops, closed circuit we can say. Okay, so let's take and let me write the weights 8, 9, 4. And this is also 8. This is, let's take 10, 7, 2, 1. It's take 9, 5, 6, 2. Okay. So this you call it as a connected graph. This is a connected graph. So one vertex is connected to another vertex. So everything is in circuit. Now let us write the step 1. So now we are converting this graph into minimum spanning tree by using Prim's algorithm. Step 1. So what is a Prim's algorithm? The step 1. So we have to select any connected vertex with minimum weight. So let us take suppose starting I'm taking A. So you have to take anything. So now I'm taking the A vertex. So here the set contains only one vertex A, and the remaining vertices that are present in this graph are B, C, D, E, F, G. Okay, and the set contains an empty. So no connected vertices are there, not there. So let me write the lightest edges to this A. What is the lightest edges to this A? So either BA or the lightest edges. This is the lightest edge. So that is AB. So that I have to select. In the step 2, I am taking A, B. Okay. So now here the set contains 2 vertices, A and B. Set contains 2 vertices, A and B. And the remaining vertices are C, D, E, F, G. And what does the set contain? A comma B. So this is the weight 4. And what is the lightest edges for these vertices? So the lightest edges are here BD or AC. So both having the 8, BD or AC. BD or AC. So but we have to connect from, we have to select the Prim's algorithm means we have to select the unvisited vertex which is adjacent to the visited vertex with minimum weight. So we have to, from this we have to select which is adjacent to the visited vertices. So we have to select the vertices which is adjacent to B. So in the step 3. And step 3. So what is the step 3? The step 3 contains with 3 vertices. A, B, and this is D. 4, 8. Okay. So we are reached from A to D. So next, this set contains A, B, D. And the remaining vertices that are present in this graph are C, E, F, G. Now the A set contains AB. These are the 2 connected vertices. And then BD. So next, what is the lightest edge to this D? Lightest edge is DC. Why it is DC? See, DC is 2. So whereas DE is 7, DF is 9. So in this 3, the least weight is 2. So we have to connect DC. So step 4, A, B, D, and this is C. 4, 8, 2. Now set contains A, B, C, D, 4 vertices. And the remaining vertices here are E, F, G. Now the set is AB, BD and DC. Okay. What is the next lightest edge to C? So the next lightest edge is CF. How does CF? Just see here. So next option, CA. If we take CA, it comes to the closed loop. Means it is a circuit. But the minimum spanning tree should not be allowed the circuit. So we have to select AB, BD, DC and CF. So in step 5, let's write the graph AB, BD, DC and CF. 4, 8, 2 and this is 1. Now this set contains A, B, C, D, F. What are the remaining vertices here? Still you are having E and G. And the set contains AB, BD, DC, CF. Next lightest edge is lightest edge. So next lightest edge is FG. Why it is FG? See here. So in this connected F, what is the adjacent to the F? We have to see the adjacent to the F or G, E and D. So if I take D, it becomes closed loop, closed circuit. So this is not possible. And if I take E, but when compared to E and G, which is the lightest weight, the less weight is the G, the 2. So I am taking this FG. Okay, so let me write that. Step 6. So the step 6 is A, B, D, C, F, G. So this is 4, 8, 2, 1, 2. Now coming to the sets. So S contains A, B, C, D, F, G. What is the remaining vertex? Only E is remaining. And what is the complete sets you are having? AB, BD, DC, CF and FG. Okay. Now, what is the lightest edge for the G? So, we have to select from G. So, the lightest edge is FE. So, when compared to here, FG and E, this is the lightest edge. So, I am selecting FE. Sorry, not, we have to visit it from the visited vertex. So, visited vertex is this. So, the 6 have to be selected from G. That is GE. Next step 7. A, B, D, C, F, G and E. 4, 8, 2, 1, 2 and this is 6. Okay. So now it completes the minimum spanning tree. Now this set contains A, B, C, D, E, F, G. So these are all the visited vertices. Now whenever the set completes, the vertices becomes the empty set. And the connected vertices are AB, BD, DC, CF, FG and GE. Okay. So now it is MST is completed. Minimum spanning tree is completed. So this is about the Prim's algorithm. Thank you.